Alright, let's look at multiplication and division. Any two algebraic terms can be multiplied together. It does not matter if they are not like terms. So in this first example here, they're not all like terms, but it does not matter. It does not matter for multiplication if they're not. So what we do for this is how I do these, 4a times 2b times a. The first thing I do is multiply the coefficients together. So I multiply 4 by 2. So multiplying my coefficients first, 4 by 2 gives me 8. Then I look at my pronumerals, and I've got here a, b, and an a. So if I multiply all those together, a times b gives me ab, and then times by another a gives me a squared b. So best to look at the coefficients first and then the pronumerals. So this next example, 7ax times by negative 6bx times by negative 2abx. Alright, let's look at our coefficients. I look at them without the sign. 7 times 6 times 2. So if we have 7 times 6 times 2, that gives us 84. I then look at my coefficients. I then look at my pronumerals. So I've got, in the first case, ax, bx, and abx. So if I multiply those all together, looking at my a's, I've got a times a, which is a squared. I've got a b and another b, so b squared. And I've got x times x times x, so it's x cubed. Now let's look at our signs. I've got a positive times by a negative times by a negative. So my positive times by a negative gives me a negative, times by another negative gives me a positive. So you can put the positive there or you can not have it there. So the answer to that one is 84, a squared, b squared, x cubed. So just remembering, any two algebraic terms can be multiplied together. Does not matter if the terms are not like terms. Again, with division does not matter about like terms. It is much, much easier, I believe, with division to change it. So we write them in fraction form. So in other words, if we have 10x divided by 5x, I think you'll find it much easier to write it as 10x divided by 5x. Because then you can see we can cancel the x on the top and the x on the bottom. 5 goes into itself once, 5 goes into that too. So the answer to that is 2. Much easier, I think, if they're written in fraction form. So this first example has got them in fraction form already, so 12xy over 4xz. We can cancel the x's, there's an x on the top and there's an x on the bottom. 4 goes into itself once and 4 goes into 12 3 times. So on the top we have 3y and on the bottom we have 1z. So that would be the answer to that one. You can just write that as 3y over z, you don't need to write the 1. That's the same thing. This next example, let's write it in fraction form. So negative 8ab squared divided by negative 16a squared b. Okay, let's see what cancels. There's 1b on the bottom and there's b squared on the top. I find a good way to write this, till we get used to it, is to write b squared as bb. And on the bottom we're going to write it as a negative 16aa b, because it's a squared. I think that shows you that you can then cancel one of the a's with one of the a's on the bottom, one of the b's with one of the b's on the bottom. 8 goes into itself once, 8 goes into 16 twice, and a negative can cancel. So on the top we are left with 1b, and on the bottom we are left with 2a. Again, we don't need to write the 1, we could just write it as b over 2a. You don't need to rewrite the b squared as bb or the a squared as aa, but I think that helps you to get started. If you don't do that, then let's go back and look at it. Another way to do it is to cancel that b with one of those. So that's gone because we've used one of those. cancel that A with one of those, so it just leaves us with the A. Then 8 into itself once, 8 into 16 2, cancel the negatives, so the answer is 1B over 2A, or just B over 2A. Okay, same thing, but showing you two different methodologies.